The joint PDF of x comma y is given by f of x comma y is equal to 1 by 240 in the interval 8.5 less than or equal to x less than or equal to 10.5, 120 less than or equal to y less than or equal to 240, 0 otherwise. Obtain the following: the marginal PDF probability density functions of x and y. Second one, E of x and E of y. Third, E of xy. And fourth, are x and y independent? Justify your answer. Okay, so this is the problem. So the given function f of x comma y is 1 by 240, x range is 8.5 to 10.5, y range is 240, 120 to 240. Okay, for other range 0. Okay, so this is given function. From the given function I want to find out marginal probability density function of x and y. Okay, so first I am going to find out marginal probability density function of x. First I am going to find out marginal probability density function of x. The formula for this is f of x is equal to integral minus infinity to plus infinity f of x comma y into dy. So this is very important one, because I want to find out the f of x, the function involving x. So if the function involving x and y, I want to eliminate y. To eliminate y, integrate with respect to y and then put the limit for y, then y will be eliminated, you will be getting f of x. So that there is the meaning of f of x formula. But unfortunately in the given function f of x comma y, there is no value of x and y. Okay, but generally the meaning of formula is this is. Okay, so now to evaluate f of x is called marginal probability density function of x. Okay, to evaluate this, integral limit is y limit, because dy. What is the limit for y here? 120 to 240. So 120 to 240. F of x comma y. What is f of x comma y? 1 by 240. 1 by 240 into dy. Okay, so here constant 1 by 240 can take outside. Integration of dy is y. The limit is 120 to 240. So now after this 1 by 240, substituting the upper limit, 240 minus 120. Okay, so now 1 by 240 into 240 minus 120 is 120. So cancel this, 1 by 1 by 2. So 1 by 2. So f of x is 1 by 2. So we can write marginal density function as f of x is equal to 1 by 2. In the interval of x is 8.5 to 10.5. 8.5 less than or equal to x less than or equal to 10.5, 0 otherwise. So this is the marginal probability density function of x. So next I want to find out marginal PDF of y. Marginal probability density function of y. The formula for this is f of y is equal to integral minus infinity to plus infinity f of x comma y into dx. The meaning of the formula is, to find f of y from the function f of x comma y, I want to eliminate y. Sorry, I want to eliminate x, then only I will be getting f of x. To eliminate x, integrate with respect to x, substitute the limit for x, then you will be getting f of y. So this is the formula for marginal probability density function of y. Okay, now to evaluate this integral, this is integration with respect to x. So we have to substitute limit for x. X limit is 8.5 to 10.5. F of x comma y is 1 by 240 into dx. Okay, so here 1 by 240 is a constant, so we can take outside, and the integration of dx is x with the limit is 8.5 to 10.5. Okay, so now 1 by 240 into substituting the upper limit, 10.5 minus 8.5. Okay, so that 1 by 240 into 10.5 minus 8.5 is 2. So that cancel this 1 by 120. So this is f of y. So finally we can write the marginal probability density function of y is f of y is equal to 1 by 120. The range of y is 120 less than or equal to y less than or equal to 240, 0 otherwise. Okay, so this is marginal probability density function of y. Okay, so next question I want to find out E of x and E of y. So now the formula for E of x. Here the random variable is continuous random variable. So the formula for E of x is integral minus infinity to plus infinity x f of x into dx. So this is the formula, but here dx. Okay, so now to evaluate this integral, the limit for x is 8.5 to 10.5 from the given given function x into f of x. Already we found f of x is 1 by 2, already we found it. So this is 1 by 2 f of x value into dx. Okay, so now the constant 1 by 2 can take outside. Integration of x is x square by 2 and limit for x is 8.5 to 10.5. Okay, so after this 2 also can take outside. So 2 into 2, 4. Substituting the upper limit. So 10.5 the whole square minus lower limit 8.5 the whole square. Okay, so now 10.5 the whole square value is 110.25 minus 8.5 the whole square is 72.25. Okay, now subtract these two. 1 by 4 into the subtraction is 38. Okay, so now cancel this 19 by 2. So finally E of x value is 19 by 2. Okay, so next I am going to find out E of y. So the formula for E of y is integral minus infinity to plus infinity y into f of y dy. Okay, so now the limit for y is 120 to 240. 120 to 240. Okay, so 120 to 240 y into f of y. Already we found f of y. What is f of y value? F of y is 1 by 120. 1 by 120. Already we found f of y into dy. Okay, so here 1 by 120 is a constant, so you can take outside. Integration of y is y square by 2. The limit for y is 120 to 240. Okay, so now this 2 can take outside, so this is 1 by 240 into substituting the upper limit. So 240 the whole square minus substituting the lower limit 120 the whole square. Okay, so now 1 by 240 into now 240 the whole square minus 120 the whole square, you will be getting 43200. 43,200. Now cancel this, you will be getting 180. Therefore E of y is equal to 180. Okay, so the third question I want to find out E of xy. Now the formula for E of xy is, it is a continuous random variable. So two random variables, so double integral minus infinity to plus infinity, x y also minus infinity to plus infinity, xy into f of x comma y into dx dy. So this is the formula for E of xy. Okay, now first the inner integral limit is x, outer integral limit is y. So the limit for y is 120 to 240 and the limit for x is 8.5 to 10.5. xy into f of x comma y. F of x comma y, it is given in the problem. It is 1 by 240 from the given function, and dx dy. Okay, so now this 1 by 240 can take outside. Next I want to integrate with respect to x, and then I want to integrate with respect to y. So I want, but you see the integral function is xy, product of two variables. The variables can be separated, okay, x and y, so that the integral also can be separate. How? Integral 120 to 240. The limit for 120 to 240 is what? Limit. This is limit for y, so that y into dy. Okay, and this is inner integral limit is integral 8.5 to 10.5 x into dx. Okay, so this is possible only if the product function can be written as x into y is xy, but x plus y cannot be written like this. Okay, so it is possible only the function can be written as product of two different variables, then only we can write. Otherwise, suppose if you have x plus y, you cannot write like this. Okay, so this is very important one. And now I am going to integrate. First integrate with respect to y square by 2. The limit for y is 120 to 240. And then integration of x is x square by 2, and limit for x is 8.5 to 10.5. Okay, so now this 2 into 2, 4 can take outside. So 1 by 240 into 4. Now here you substitute limit 240 square minus 120 square, because upper limit minus lower limit. Here also, after taking 2 outside, this is 10.5 the whole square minus 8.5 the whole square. Upper limit minus lower limit. Okay, so now after this, 1 by 240 into 4. Now using your calculator, you can simplify. The value is 43,200, and using your calculator you can simplify. You will be getting 38, and use your calculator, you will be getting the values for this is 1710. So this is the answer for E of xy. So finally E of xy is equal to 1710. So next question is, are x and y independent? Okay, so the condition for independent, condition for independent is f of x comma y is equal to f of x into f of y. So this is the condition for independent. Okay, so now here already we found f of x and f of y. So f of x into f of y. We found f of x is 1 by 2 and f of y is 1 by 120. This is also we found. So multiplication of these two is 1 by 240. But this 1 by 240 is given f of x comma y. This is from the given function. So that f of x comma y is equal to f of x into f of y. So the condition is satisfied. Therefore, x and y are independent. X and y are independent. Okay, so the problem is over.